Okay, so what we're going to look at now is carbonyl compounds. Okay. Carbonyl compounds, there are two kinds of carbonyl compounds that we need to look at. We need to look at aldehydes and ketones. Okay. An aldehyde, both of them contain this functional group. Okay. But there's a very important difference between them. For an aldehyde, the group we must have, well, it could be that R group there could be a hydrogen, but is most likely to be a carbon chain of some sort and a hydrogen. So what makes an aldehyde is that I've got that carbon double bonded to oxygen and a hydrogen atom. So it is that makes that an aldehyde. And on the ketone, I have two different alkyl groups. So in a ketone, I've got two carbon atoms attached to the carbon that is double bonded to oxygen. In the aldehyde, I must have at least one hydrogen. That could also be a hydrogen, but I must have at least one hydrogen. In terms of nomenclature, the aldehyde, the name ends in Al. So you know the naming of an alcohol. So here we have an aldehyde. The name ends in Al. For a ketone, the name ends in ONE. Presuming, of course, that the ketone is the major functional group. Just one last thing to talk about with aldehydes and ketones is to look at the nature of that group. Remember, we've got two lone pairs of electrons sitting on that carbon atom. Because the carbon is more electronegative than the oxygen, sorry, the other way around, because the oxygen is more electronegative than the oxygen carries a delta negative, and the carbon carries a delta positive. That makes that carbon atom, the carbonyl carbon, is then an electrophilic center and so susceptible to attack by electrophiles. And the other important thing, just to note there, is that that carbon atom is an sp2 center. So that is, of course, trigonal planar. So there's trigonal planar geometry around the carbonyl carbon.